Yeah, there are 2 points I have considered here, point A and point B. You can see here, this is point A and this is point B. So I try to find a vector which is joining these 2 points A and B. So we know that the difference between scalar and vector. So the scalar is having only the magnitude and the vector is having both magnitude and direction. Now the thing is, now if I want to write a vector joining the points A and B, see the point A is located at 1, 2, 3 with reference to the origin. So this is your origin. And the point B is located at 4, 5, 6 with reference to the origin itself. So then you need to find out what is the vector joining both A and B. Somebody is having some question? So everybody is audible, right? Some queries are here. My voice is audible, right? Okay, fine. Now we try to write a vector joining the points A and B. So how to write the vector? See here, using the vector law of addition, suppose you start from the origin. So what will happen? Origin to the point A, I was defining it as a vector OA bar. And then A to B, I was defining it as a vector R bar, which we need to find out. And then O to B, I was joining it as a vector OB bar. Now see, using the vector law of addition, what we can say? OA bar plus R bar is equals to OB bar. Right? So I can say the vector joining the points A and B, R bar is equals to OB bar minus OA bar. So hence, yeah, so R bar can be written as OB bar means the position B is located at 4, 5, 6 minus, and position A is located at 1, 2, 3. So what will be the value? So the simple hint was, when you want to write a vector joining from A to B, the vector can be written as the final point minus the initial point. So the final point is nothing but OB bar. So the vector is nothing but the final point is OB bar minus initial point is OA bar. So OB bar is 4, 5, 6 and OA bar is 1, 2, 3. So what will be the value here? 4 minus 1, 3, 5 minus 2, 3 and 6 minus 3, 3. So I
One
can
moment,
say,
sir.
yes, sir.
Sorry, sir, for interruption. Can you
Yes,
please
sir.
put on pause recording?
What is that, sir? I didn't get you.
No, please put on pause recording. Two, three guys still have to join. They have some little difficulty, so we will wait just for them.
Fine, sir. Fine, sir. Fine. For how much time, sir?
Just 2 minutes. 2 minutes. 2 minutes.
Right.
Just
okay.
yeah. Sir, can put on pause recording.
On the right-handed sequence on the cross product. So row to phi is the right-handed sequence, phi to z and z to rho. So please write the cross product. What will happen? A rho cross A phi will become positive AZ and A phi cross AZ become positive A rho and AZ cross A rho becomes positive A phi. And please do the same thing for spherical also. R, theta and phi. So R to theta, theta to phi and phi to R. So you can do the same thing. AR cross A theta is equal to A phi and A theta cross A phi is equal to AR and A phi cross AR is equal to A theta. This is a cross product. So is it clear? Now I will ask a question, please reply me. So what is the cross product of A rho into AZ? So what is the value of A rho cross AZ? Tell me your answers.
Minus A5.
Minus A5. So you understood, right? The moment once you go in a left-handed sequence, the answer will be negative. If you go in a right-handed sequence, the answer will be positive. So we have seen the dot product and the cross product in this slide. So let us move on to the next one. So in this section, we will understand the differential length and the differential area and the differential volume. So see here, this is something like a parallelogram I have considered here. So something like some surface is located here in the space. Now, what will happen? First, you see the differential length part. Differential length part. Suppose you consider this is your point A. You are starting from this particular point, and I have to reach the point D here, somewhere which is located here. So what is the first path you can consider? You can say, I can move from A to B, and again B to C, and again from C to D. Right? So when you are moving from A to B, in which direction you are moving? Please tell me. Moving from A to B, you are moving in which direction?
Y direction.
Yeah, B to C.
Minus X.
Yeah, fine. But you can say there is a change in X. And C to D?
Z axis.
Yeah. Now, the thing is, when I was moving from A to B, you are moving in Y direction. And B to C, X direction. C to D, there is a change in Z direction, right? Now, I will split it something like this. So I can say that when I want to move from A to D, something like this. So you are covering a particular length, right? So that is the sum of A to B plus B to C plus C to D. Now, A to D, I was calling it as some differential length you have covered. So that represents a vector, right? Is equals to A to B, you are moving in the Y direction, right? So there is some change in the Y happened. So I can represent that vector by dy ay cap plus B to C, there is a change in X happened. So that will be dx ax cap and C to D, there is a change in Z. So there will be dz into az cap. So this represents your differential length vector. So the moment once I move from A to D, there is a change in X happened, there is a change in Y happened, and there is a change in Z happened. You can see here all these things are linear directions. Because whatever the direction you are moving, you are exactly moving in a straight line direction. So there are no angles involved in it. So that is the reason why if you see the dx multiplier, here multiplier is 1. All the multipliers are 1 because you are moving in the linear direction. Clear?
Sir, how
Yes.
is AD a differential length?
No, I was moving from A to D means I have considered something like I should cover a distance, right? Whatever the distance I have covered, I was representing it with a vector.
Okay.
Understood? I want to move from
Yes.
point A to point D. I should cover some finite distance. That distance, I was calling it as a vector. Is it clear?
Okay.
That vector will be obtained by taking it in a different path. You can go it in a different path also. Something like A to H you can move, H to E you can move, and E to D. But ultimately, if you want to reach from A to D, you should consider all the three directions. You cannot reach from point A to point D just only by covering in X direction, only by covering in Y direction. So if you want to move from A to D, here three variations must be definitely required. So that is the reason why I have taken one particular path in this way. So there is a change in x, change in y, and change in z. So that is called the differential length. Now we will move on to the differential area. So this is very important. Try to focus here. So consider the surface A, B, G, and F. Yeah. Consider the surface A, B, G, F. So what is that surface? This is your surface A, B, G, and F. This is the surface. So when you move along this surface, can you tell me what is the directions which are changing?
Why is it?
A to B, you are moving in a y direction, and B to G, you are moving in a z direction. So whenever considering any differential surface, you remember A to B, there is a change in y, B to G, there is a change in z. So using a rectangular area, you can say what is the surface area? There is a change in y happened, and there is a change in z happened. And since this is a vector, it is associated with a direction. So what is the direction of this particular surface represents? You can see here, the moment once you consider any surface, the direction represents a vector which is perpendicular to the surface. So can you tell me which direction is perpendicular to this plane?
X.
X.
Yeah. So whatever the perpendicular direction to this surface, it represents the direction. So that I can call it as Ax cap. So I will give you one more shortcut also. So the moment once you move along the surface, whichever is not varying, or in other words, whichever is the constant parameter, that represents the direction. So now when I was moving from A, B, G, and F, always Y and Z are changing. X is not changing, right? So since X is not changing, so definitely that represents the direction of my surface. So similarly, you please write down for B, C, D, and G also, and F, G, D, E. Write down and tell me the answers. So consider the surface B, C, D, and G. So this one. So when you move from B to C, what is the variation? That will be dx. And again from C to D, you are moving in the direction of Z, right? dx into dz. And since x and z are varying here, whatever the constant here is nothing but y. So the direction represents ay cap. So there is a change in x, change in z, and keeping y as a constant. So the next thing, F, G, D, E. So this is the surface you consider. Please consider this. And write down the change in surface area. F to G you are moving. There is a change in y happened. And G to D, there is a change in x happened. So there is a change in x and y. So Z is a constant. That represents a Z cap. So in the first case, yeah.
If we write like dy dx az cap, then there should be minus.
No, I was telling that change can be negative. So I was not bothering about whether dy is positive or dx is positive, right? That is a differential length. That is a change in the length.
Okay,
So
sir.
in this case, x will be negative. So suppose the moment once you move from G to D, you are moving in a negative x direction. But my intention is not particular on whether it is positive or negative. There is a change. That change can be either positive or negative, right?
Yes, sir.
Yeah. So now, if you consider ABGF, what is constant here? Which one is a constant? X is constant, right? So this surface represents x is equal to constant surface. And when you consider the second one, BCDG, x and z are varying and y is a constant. So this represents a surface where y is a constant. And the third one, xy are varying. So this represents a z is a constant. Right? So next move on to the differential volume. So what do you mean by differential volume here? So you consider this particular surface only. Volume means you are multiplying the variations in each and every direction. So how to write the differential volume? So if you consider the full surface something like this, it is having the y variation and this is the Z variation, and this is the X variation. So the differential volume can be written as dx, dy, and dz. Is the volume is a scalar or a vector?
Scalar.
Scalar. Volume is just a number. So if you want to find the volume, you just multiply the variation in each x, y, and z directions. Sorry. So in the rectangular coordinate system, have you understood the differential length, area, and volume? So any questions, please try to clear it now only in this slide. Shall I go ahead?
Yes, sir. Yes, sir.
Yeah. So next one, we'll see the same differential length, surface area, and the volume in case of cylindrical, right? So please see the diagram here. You can see this is a diagram. So whatever part I have considered here, right? This is a small cross section of the cylinder I have taken. So you had a big cylinder. For the demonstration purpose, I have taken a small part of the cylinder, something like this. This is your outer surface. And see here, before discussing about the differential length, all of you see here, this is your point which lies on the z-axis. And this is point A. From the z-axis, and if you are moving on to point A, please tell me what direction you are moving. I was moving, rho is varying, right? And now from point A, I have to move on to point B. So which is varying there? There also rho only.
Rho.
Now, yeah. So when the point is here, your rho may be, let us say, 1 unit. And the moment once you move to point B, your rho will be increasing, right? So rho will be something becomes 2 or 3. So the moving from A to B, it corresponds to the variation in rho. Correct? Next, you please see moving from B to C. When you move from B to C, what will happen? You are moving parallel to the z-axis, right? So moving from B to C, you are moving parallel to the z-axis. So what will happen in that case? There is a change in Z. Correct? Next, moving from C to D, what is going to happen?
Change in phi.
Change in phi. Why? Because, for example, for that, I have given one explanation here. The point C, you try to project it onto the ground plane. So this is a point after projecting point C. And this is the same point after projecting point D. So see here, the distance from here to here is same as the distance from here to here. So that value is same as rho only. And once the point is moved here, the same thing here. So since it is on the same cylinder, the radius remains same. So the distance you covered from C to D is same as the distance you covered from these 2 points after projecting. So all of you see here, this part you can see here. When the point is here, there is an angle of something like phi 1. When the point is phi here, from the x-axis it is very far, so there is a change in phi. So the moment once I move from here to here, which is same as here to here, there is a change in phi which has happened. Right. Now let us try to write down one by one. So I want to move from same case point A to point D. So I can take the path something like this. Moving from A to D can be done by moving from A to B and again from B to C and again from C to D. So this I can call it as a vector dl is equals to. So when you move from A to B, please tell me what is the vector.
Rho. Rho.
Can you tell me in terms of vector? Moving from A to B. So
D
moving
rho
from A,
cap. D
yeah,
rho.
there is a change in rho, d rho, a rho cap, plus when you move from B to C, what will happen? There is a change in Z. So I will write down that is dz into az cap, plus when you move from C to D, what will happen? The moment once you move from C to D, you are not moving in a linear direction. You are moving in a direction where there is a change in phi that has been happened. So what is the distance you covered when you move from C to D? is same as after projecting the point something like this. Let us say C dash and D dash. So the distance between C and D in an angular path is same as the distance from C dash to D dash. Now you consider this is the value of which is nothing but rho, and this is also rho, and there is a change in angle of d phi here, right? Now you can look at this particular part. So this represents a sector where the radius is rho and the angle between them is d phi. So what is the length of the arc in that case? The length of the arc is nothing but the radius multiplied by the angle between them. So I can say the length of the arc is nothing but radius is rho and the angle between them is d phi. So whenever you are moving in the direction of phi, it is not a linear direction, it is an angular direction. So the change in phi will be rho into d phi. So when I want to move the direction from C to D, the variation happened is nothing but rho to d phi. So into a phi cap. So any questions here? You understood what is the distance when you are covered, when you are moving in the phi direction. So why it comes like rho into d phi? Is it
No,
clear?
sir. No, sir. So, when there's a change in the angle, so
Yeah,
we say that change in the angle itself is d phi, right?
exactly.
In y
But you can say
direction.
the change in angle is d phi if we move linearly, right? But now in this case, see here, you are moving from C dash to D dash. Are you moving in a linear direction? That means straight line direction?
Okay,
Yes or
okay.
no?
No, sir. No.
You are not moving in a straight line direction. When you moving in a straight line direction, simply you can say either dx or dy or dz like that. But in this case, you are not moving in a linear direction. So what will happen? Since this represents the length of the arc, where the radius vector is rho, so the length of the arc is nothing but the radius multiplied by the angle between them, right? So that will be rho into d phi. So when
Okay.
you are moving in the direction of phi, there is a multiplier which comes in picture, that is rho. Is it clear now?
Yes, sir. Yes.
Yeah. So remember, there is only one shortcut throughout the coordinate system. The moment once you move in a linear direction, there will not be any multiplier, which means that you can straight away say d into 1, dz into 1, or dx into 1. So the moment once you go in a direction where there is a linear change, you straight away get dx, dy, dz, d rho or dr, something like that. But whenever there is a change in the angular direction, there will be a multiplier. So the change in phi is having a multiplier of rho. Clear? Now, let's move on to the differential area. So when you see the differential area, first consider the surface GBCD. Where is that? Yeah, this part. G, B, C and D. So please tell me, when you are moving on this surface, what all the variation happens? Look at this particular surface, what all the variations are happening?
There's a change in phi and there's a change in the z direction.
Yeah, then in that case, what is the value of different surface you can say? So when there is a change in phi, what is the value you will get? You should not say d phi, right? You should consider into d phi. And when you move from B to C, there is a change in Z. So simply it is right away dz. And what is going to be constant in that case? Since phi and Z both are varying, whatever the constant, that represents the direction of the surface. So the direction of surface is a rho cap, since rho is constant. Clear? Similarly, you please take time and try to write the surface area for these two. For these two. So you can write the surface area for these two. And I was writing the board for you. You can please write down here straight away. So first write down for F, G, E and D. So when you are moving from F, G, and D, this is the surface which represents that. So F to G, there is a change in rho, right? And G to D, there is a change in Z. So since rho and Z both are linear directions, so straight away you will get d rho into dz. And since phi is not changing, which is a constant, so the direction is a phi cap. So that is a phi is a constant. So next moving on to A, B, G, F. So this is the one, A, B, G, F. This is the top surface. So what is going to vary here now? A to B, so there is a change in rho, and B to G, there is a change in phi. So rho is changing and phi is changing. So since rho is changing, the variation is d rho, and phi is changing, the variation will be rho into d phi. So rho phi are changing here, and the constant is the z, so that represents the direction. Since z is a constant, direction is az cap. So similarly, next one, the one is a differential volume. You consider this entire surface. So if we move along the surface, there is a change in rho, change in z, and change in phi. So the differential volume can be written as, the change in rho will be straight away d rho. The change in phi will be rho multiplied by d phi. And the change in z will be straight away dz. So the differential volume will be rho, d phi, and dz. Any questions here? Shall I go ahead? Or you can clarify your questions in this slide.
Clear, sir.
Yeah, so let us move on to the next slide. So now we will see the same differential length, area, and volume in case of a spherical system. Again, the same thing here, all of you. So this is your point of interest. This is your origin. And from the origin, if you are moving on to point A, it corresponding to what variation?
dr.
Please tell me. dr.
Rho.
And A to, it's not rho. See, rho means when you are moving away from the z axis, right? Now, I was moving away from the origin. So in the last class, we have seen the moment once you move away from the origin, so the radius is going to be changes. That is nothing but r. So when you move from A to B, there is a change in r. So the different, since it is a linear distance, the variation you can say it as d into r, right? Now, what will happen when you move from B to E? See here, let us say the point B is at a certain angle of theta, and point E when you are making, the radius remains same. When you are moving from point, yeah, please.
R d theta.
R into d theta. That means there is a change in theta. So we'll see what is the value of that. So B to E, there is a change in theta. And moving from E to D, just now in cylindrical we have seen, right? So the moment E is projected here, this somewhere lies here. So it corresponding to a particular rho and a particular phi. And point D, when you are projecting it here, it corresponding to the same value of rho, but there is a change in phi. But there is a change in phi. So there is a change in phi here. Now let us try to write a vector from A to D. All of you try to write a vector from A to D in the same fashion. So when you are writing a vector from A to D, so how you can move? Same thing, A to B, B to C, and C to D. A to B, B to C, and C to D. So write down and tell me the answer now. So the vector dl bar is equal to, since you are moving from A to B, there is a change in R happened. That will be dr into AR cap When you are moving from B to C, what is going to change? B to C variation is same as E to D. So E to D, what is the variation it is happened? Rho into D phi, right? What is the value of rho in spherical? Anybody? What is the value of rho in spherical?
R sin theta.
Yeah. So the change when you are moving from B to C, the variation will be rho into D phi. Now, instead of rho, what I will say? R into sin theta. So rho is equal to R sin theta, and there is a change in of phi into A phi cap. So what is the distance when you are moving from C to D? So when you are moving from C to D is same as moving from B to E. Both are parallel. And this time also you can see here, this is not a linear distance. When you are moving from B to E, what happens? B is corresponding to a particular theta and E corresponding to a particular theta, but the radius remains same. So the distance from origin to B, you can call it as R. And the distance from O to E is also, you can call it as same radius R. And there is a change in the angle here, d theta. Now what will happen? Since this represents the length of the arc is nothing but the radius times angle between them. So radius is R into angle is d theta into there is a change in theta. So the point is here, when you are moving in the changing of phi, the multiplier will be rho. When you are moving in the change of theta, the multiplier will be R. That's it. So since it is in a spherical, the value of rho I have replaced with a R sin theta. Now, by considering this, you try to write down the surface area for all these surfaces. B, C, D, E. First write down for B, C, D, E. Then we'll discuss about for remaining things. So please take time and write down all the surface areas for this. So when you are moving from B, C, D and E, you can see here what is varying here. We see there is a change in phi, and C to D there is a change in theta. Right. So what is the surface area here? The change in phi will be rho into d phi. So that means rho is nothing but R sin theta into d phi. And C to D there is a change in theta. So there is a change in the theta will be R into d theta. By keeping which one as a constant? So since theta and phi are varying, the constant one is the R, which represents a direction. So the final value will be R square sin theta d phi AR cap. So this is for R is equal to constant. Similarly, look at F, E, D and G. F, E, D and G. So this is the one, F, E, D and G. So it is simple. When you are moving from F to E, there is a change in R, right? And when you are moving from E to D, there is a change in phi. So what is the surface area? Moving from F to E, there is a change in R. So that is straight away dr. And moving from E to D, there is a change in phi. So change in phi will be rho into d phi. So that is same as R sin theta d phi. So since R is varying and phi is varying, so which is constant here now? Theta is constant. So that will be a theta cap. So where theta is a constant parameter. So the second one represents theta equal to constant. So similarly write down for ABEF. ABEF means this is the part, this part. Same thing, A to B there is a change in R and B to E there is a change in theta. So the surface area will be change in R will be dr and change in theta will be R into d theta. So since r and theta are both are varying, the constant is a phi. So phi is a constant. So next move on to the differential volume. So what is the differential volume here? So when you see the differential volume, there is a change in r, there is a change in theta, and there is a change in phi. So the change in r will be dr. The change in theta will be r into d theta. And the change in phi will be rho d phi. That is nothing but r sin theta into d phi. So any questions? You take some time and see both the rectangular, cylindrical and spherical. See the differential length, area and volume. Sorry. Tell me, what is the change in rho happened when it is a cylindrical? There is a rho, phi and z. So what is the change in rho that will be happen? Hello, am I audible, right?
Yes, sir.
Yes, sir.
Yeah, so please tell me what is the change in rho, phi and z, what you have seen. Whenever we are moving in the rho direction, what is the change happen?
Zero.
Zero.
Change in phi?
Rho d phi.
Rho d phi. Change in z?
Dz.
Dz. So what is the multipliers here? 1 and 1. Right. So similarly, we'll see for spherical. So there is a change in r, there is a change in theta, there is a change in phi. So please tell me one by one. So change in r will be?
Dr.
Change in theta?
R d
R d theta.
theta.
R d theta. Good. And change in phi will be?
R sin theta d
Yeah.
phi.
Yeah. Change in phi will be, you remember, you forgot about that. Change in phi will be multiplier of rho will be present. Right. So rho we can be replaced with r sin theta in a spherical. So what is the scaling factors or multipliers here? 1. And there is a multiplier of r here, and there is a multiplier of r sin theta. So this is what we have seen, right? Now let us go back to the presentation. So now we'll try to move on to the next concept, that is called the several vector operators are there. So gradient, divergence and curl. So first one, we'll see the gradient one. So what do you mean by gradient? So the gradient represents the rate of change of any physical quantity. Some simple example for gradient was, suppose you are moving from one point to the other point, so you are able to cover a finite distance. So to cover the distance, there will be always a velocity or the speed associated with that. So how to say that if you want to define your velocity, that is the rate of change of distance you covered within a distance within a time of t, right? So in this case, what is the gradient represents? So I can say the velocity is the gradient of the distance with respect to the time. So the gradient is simply nothing but the rate of change of any physical quantity. And the direction of the gradient lies in the direction of maximum rate of change. See here, whatever the direction of the vector velocity here, which will be in the same direction where the maximum change in the distance happened. So since the output velocity is a vector, the direction will always lies in the direction where there is a maximum rate of change. And in other words, suppose if you have any particular surface, the gradient of the surface represents a perpendicular vector. So the third point is gradient of any surface represents a vector perpendicular to it. For example, you take an xy plane. So xy plane is represented with z is equal to constant, right? So when you apply the gradient for this particular surface, this represents a vector which is perpendicular to it. So which is the perpendicular vector to this? We already seen right now, since this is z equal to constant, there is a change in x, there is a change in y. So the perpendicular vector will be the z itself. So the gradient of any surface represents a vector which is perpendicular to it. And you can see here, whenever you apply a gradient, the gradient must be applied on a scalar and the result must be a vector. Simple example is this one only. So when you are applying the gradient on something like distance, which is, you can say, input is a scalar and the output is a vector. So this is the general equation I have given, irrespective of whether it is a rectangular, cylindrical or spherical. So please go through the formula. So here k is some scalar quantity. Then the gradient is defined as del k. Del is nothing but a spatial operator. So the meaning of del was, so in what direction the rate of change happens. Suppose I was moving from one point to the other point. If there is a change in only x happened, then del represents the rate of change in x direction only. Suppose in addition to the x variation, if there is a change in y also happened, you can say that will be dou by dou y. And in addition to that, if there is a change in z also happened, you can say dou by dou z. So the spatial operator represents in what directions the rate of change occurs. So I was combinedly writing here del k is equal to, so as simple as this, you can take an example of the rectangular. In that case, u, v and w represents x, y, z itself, because that is the spatial variations in a rectangular. So that will be straight away dou k by dou x, ax cap, dou k by dou y, ay cap, plus dou k by dou z, az cap. Now, there is a scaling factors here, h1, h2, h3. Can you please tell me what is the scaling factors? So see, this is the generalized expression irrespective of whether it is a rectangular, cylindrical or spherical. If it is a rectangular, what you need to do, u, v, w should be replaced by x, y, z. If it is a cylindrical, replace it with rho, phi and z. If it is a spherical, r, theta and phi. Now, why I have included a scaling factors here? Can anybody say the answer for that?
So because in case of cylindrical, we'll get rho, and in case of spherical, we get r and r sine theta for.
Exactly, that is the reason. Because when you move in a rectangular, you are moving in always in a linear direction. So this h1, h2, h3 doesn't bother for you. Now, whereas if you take a cylindrical system, rho is a linear direction, z is a linear direction. But when you are moving in a phi, there is a scaling factor of rho. Similarly, when you move in a spherical, r direction is a linear. But whereas if you move in a theta, the multiplier will be r there. When you are moving in a phi, there is a multiplier of r sine theta. So since this is the expression represents a generic equation irrespective of rectangular, cylindrical or spherical, I was writing it as a h1, h2, h3. So these h1, h2, h3 are called the scaling factors and u, v, w are the spatial variation parameters. So with this next slide, we'll try to expand this equation in terms of rectangular, cylindrical and spherical. So you can see here, what is the scaling factors we have discussed in case of a rectangular? So h1, h2, h3 are corresponding to x, y, z if it is a rectangular. So since x, y and z all are linear variations, the multiplier will be straight away 1. We have already seen this. What happened when it is a cylindrical? In cylindrical, H1 and H2, H3 represents rho phi z. So when you move in a rho direction, multiplier will be 1 because it is a linear distance. When you move in a phi direction, what is the change you got? Rho into d phi. So there is a multiplier of rho. And when you move in a z direction, straight away you are calling it as dz. So the multiplier will be 1. Similarly, in case of spherical, what will happen? H1 represents R variation. So in R variation, you got dr, right? So the multiplier will be 1 itself. H2 represents theta variation. In theta variation, you have R into d theta. So the multiplier will be R itself here. And when you move in a H3 direction, you are moving in phi. So in phi direction, you already had rho into d phi. So that will be R sine theta into d phi. So the multiplier will be 1 R sine theta in a spherical. So what is the spatial variations? In case of rectangular, you may have change in x, y as well as z. Cylindrical means rho, phi and z. In case of spherical, r, theta and phi. So is it clear for everybody what is the scaling factors and what is the spatial variations?
So in scaling factors, why is it 1 by h1, 1 by h2? Like, shouldn't it be h1, h2? Why is the reciprocal given in the formula?
Yeah, just go back to the slides. Here, there is a change in phi represents. Is it in the numerator or denominator? Numerator is just a scalar, right? You are taking the variation in the denominator part. Right?
Okay.
See here, for example, if it is a cylindrical system, rho phi z comes in place of UVW, right? So that is in the denominator part only, right? So for the denominator part only, you should multiply the scaling factor. So the scaling factor should be applied wherever the rate of change occurred. So here the rate of change or the differential length will happen in the denominator. So that is the reason why I have taken 1 by h1.
Understood, sir.
Yeah. Then move on to the next one. So like this is the generic equation, right? So what you guys tries to do. So now you already know. Suppose if you write in a rectangular, you try to expand what is the gradient. So you take one thing, h1, h2, h3 from the table. All are 1, right? And w will be replaced with x, y, z. So please write down rectangular, cylindrical and spherical. You try to practice it, this one. So I want to write the gradient equation in rectangular, cylindrical and spherical. So in all the cases, k remains constant and you replace the scaling factors and the spatial variations accordingly. So write down. So I was writing it here. Del k will be straight away. In rectangular, I will forget about the scaling factors. I will not bother about that. So that simply represents the rate of change in x into ax cap plus dou k by dou y, ay cap plus dou k by dou z, az cap. Similarly, in case of cylindrical, what will happen? There is a change in rho. So dou k by dou rho, a rho cap plus there is a change in phi. So that means dou k by dou phi and phi is having already a scaling factor which is 1 by rho into a phi cap plus h3 will be 1 in cylindrical. So dou k by dou z, az cap. So similarly, in case of spherical, the value of del k is equals to, so h1 will be 1 because it is a r variation. So dou k by dou r, ar cap plus h2 will be r because v corresponding to theta variation. So when you have a theta variation, the scaling factor is r. So dou k by dou theta, a theta cap plus dou k by dou phi. So in case of phi, there is a multiplier of rho. So rho will be replaced with a r sin theta. K by dou phi into a phi cap. clear all of you?
Yes, sir.
Yes,
So
sir.
finally the summary is gradient is nothing but the rate of change of any physical quantity. And when you apply a gradient, the gradient should be applied on a scalar and the result will be a vector. And the direction of the gradient represents the direction where there is a maximum rate of change. So when you are writing whether it is in a rectangular or cylindrical or spherical, you are combinedly writing what is the variation in each and every direction. So that you seen in a rectangular. When any problem is given, suppose if k is a function of x comma y comma z, which means that k is varying in all the three directions. I want to find out what is the gradient in k. So simply you differentiate this function with respect to x, y and z respectively. That's it. But whereas if you go for cylindrical, you should differentiate with rho and differentiate with phi and z, but be careful in applying the correction factors, or you can say the scaling factors. So if it is a rectangular, it doesn't matter. Straight away you can take the differentiation. But when you go in a cylindrical, in addition to the differentiation, there is a multiplier. So you have to take a look onto that. Similarly, in spherical also, you take the differentiation along with the multipliers. So we'll see some problems on this in the next one after discussing the theory part. So move on to the next one, divergence. So what is the divergence represents? The name itself indicates, suppose if you have a source something like this, if the effect because of this source is radially outwards, I can say that there is some amount of divergence. So the divergence represents the net amount of the outward flow from the source. If anything is coming out of the source, you can say there is some amount of the divergence. For an example, you can take an example of an electrical bulb. So you know that the electric bulb will produce the flux in each and every direction like this, omnidirectional. Now, I try to capture the flux with a closed surface. Now, how will you find out the divergence in this case was, you calculate how much flux is leaving out from the source. You calculate the total flux generated from this source divided by the volume of the enclosing surface. So you can see the definition. So the divergence represents what is the net outward flow per unit volume. So how much flux is coming out from the source, you can add up total flux that divided by the volume. So whenever you are applying a divergence, divergence is basically a dot product. So when you apply a dot product, the input must be a vector. And since the dot product output is a scalar, so the output of the divergence is a scalar. So the divergence when you are applying, it should be operated on a vector and the result is a scalar. So the input must be a vector and the result must be a scalar. So what will happen here? Now let us consider something like this. Again the same thing, UVW represents the spatial variations irrespective of whether cylindrical, rectangular or spherical. So DU, AU plus
Sir, your voice is breaking.
because am I audible? Something is happening here.
So your voice was breaking.
Voice is breaking, huh? Yeah, just
Yeah.
a second. Now am I
So your voice is still breaking.
No, still not yet solved, but not solved. Just so just cross check once again. Am I audible or not?
Yes.
Yes, sir, you're audible now.
No audible. Right. So in this section, we are discussing about the divergence. So the divergence represents what is the net outward flux divided by the volume. For that, I have considered a vector something like this. Divergence is defined as given by this equation. So the divergence is given by this equation. You can compare this. As I said, divergence represents the flux divided by the volume. So you can consider it in a rectangular. What will happen? H1, H2, H3. Dinesh sir?
Yes, Shiva sir.
Am I audible, sir? Because I'm getting some problem from the students. Voice is breaking or
Yeah,
something.
no, you are audible, sir.
No,
Okay.
okay, no, sir. Right.
Yeah, okay. And if it is that I suggested, na, you can connect through mobile, okay, where you connect audio, it will work very well, sir.
Right.
Okay, sir.
Okay, sir. Okay.
Yeah. Thank you, sir.
Right. So the divergence is defined as the per volume. So you know that H1, H2, H3 represents the multiplier. So suppose is in X, Y, the multiplying H2, H3 is indirectly represents the volume part, right? So this part is compared. What is the next remaining part here? Whatever I have written here. Suppose when you have a parallelogram or something like this, when you have a cube thing like this, assume that there is a point charge which is located at the center of this and the flux will be directed in all the directions. If I want to capture the total flux, I should capture what is the flux leaving in YZ plane and what is the flux leaving in XZ plane and flux leaving in XY planes. So the total flux is because of how the flux is getting through all the surfaces. Now you can see here the first one H2, H3 corresponding to Y and Z in case of rectangular. So the first parameter represents the variation of the flux leaving in YZ plane and the second parameter represents the variation of the flux leaving in XZ plane and the third one represents the variation of the flux leaving through XY plane. So the flux leaving YZ, XZ and XY plane altogether forms the total flux leaving the entire room. So this part represents the total flux and this part represents the volume. So the divergence is basically defined as the total flux generated from the surface divided by the volume. Now, if the divergence of any vector is said to be zero, the vector is basically said to be a solenoidal. So the meaning of solenoidal you would have been understand in your academics. Suppose solenoid is nothing but a simple magnet. So when you have a magnet, the flux lines will be originating from the north pole to south pole like this. So all the solenoid, there is only the nature, which means flux is coming originating from the source and ending towards the source only. So there is no divergence nature. So when I say divergence nature, everything should be radially outward from the source. Whereas if you see the solenoid, there is nothing will be going outside. So what going out, it again coming back to the source. So which is said to be the rotational nature. So that's what I can say. For a solenoid, there is no divergence nature existing. So that is the reason why if the divergence of a vector is zero, then the vector is said to be solenoidal. Now consider this example, this scenario, this one. So this is my source and this is my effect. So what will happen in this case? All the flux lines are radially moving outwards from the source. So whenever the flux is radially outward from the source, you can say there is a positive divergence. That means everything is moving radially away, or you can say radially outwards. Radially outwards, the divergence is said to be positive. So consider the second scenario where there is a radial nature or divergence nature is existing, but this is radially inwards to the source. So all the flux is getting entered towards the source. So then I can say there is a negative divergence. So whereas in this case, third case, if you see here, what will happen? There will be some amount of flux leaving from the source, and there is some amount of the flux entering to the source. So whatever the flux is entering, the entire thing is leaving. So I can say there is a zero divergence. So whatever is entering into the node, the entire everything is leaving. So I can say the net effect will be divergence will be zero. So we'll see in the next slide what is the divergence in a rectangular, cylindrical, and spherical. As I said, this is your generic vector, irrespective of whether it is a rectangular, cylindrical, and spherical. So the divergence equation I have given there, you can see here, I have explained as well. So in case of a rectangular, suppose if I want to write down, so what is the vector you will consider? Dx Ax cap plus dy Ay cap plus dz Az cap. Then what will happen to the divergence? So please write down the divergence. So replace h1, h2, h3 with the multipliers 1, 1, 1, and instead of du, dv, and dw, what all the coefficients exist here? Dx, dy, and dz. So please take time and try to write down the expression for del dot d. So please tell me what is the value you got. Apply the scaling factors and du, dv, dw you replace with the coefficients of the vector. So please tell me any one.
Dou by dou x of dx plus
Yeah,
dou by dou y of dy plus dou by dou z of dz.
right. So if it is over, you try to write down for cylindrical and spherical also. In the meantime, I will give an example. So when any problem is given, I will tell you a simple shortcut here. Suppose if the vector is something like this. X Ax cap plus Y Ay cap plus Z Az cap. If you want to find the divergence in case of rectangular, next time you don't remember the formula, I'm going to give a simple shortcut here. Differentiate Ax coefficient with respect to X. So that means differentiation of X will be 1 plus differentiate Ay coefficient with respect to Y. So again it is a 1 plus differentiate Az coefficient with respect to Z. So that is also 1. So the divergence is straight away 3. So when any problem is given in rectangular, next time you need not to remember the formula. Simply differentiate Ax coefficient with X, Ay with Y, and Az coefficient with Z, and finally add together. So that represents the divergence in a rectangular system. So is it clear? Shall I move on to cylindrical now? Shall I move on to cylindrical?
Yes, sir.
Yeah. So take the same equation again and consider a vector something like this. D is equals to d rho a rho cap plus d phi a phi cap plus dz az cap. Then write down the divergence equation. So what you need to do, h1, h2, h3, if you see here, that will be respectively 1, rho and 1. And du, dv, dw, you replace with d rho, d phi and dz. So finally, what is the equation you will get? I will try to write down here. Del dot d is equal to 1 by So if you multiply all the scaling factor, that will be rho, dou by dou rho of H2, H3 will be rho into 1. So that will be rho into d rho plus dou by dou phi of H1, H3 will be 1 into 1 and dV will be same as d phi plus dou by dou z of H1, H2, that will be 1 into rho. So that will be rho into dz. So this represents the divergence equation. Now I can further simplify this equation something like this. So delta D is equals to, so answer me, can I take rho common from the first term here? Shall I take rho common from the first term and get it cancelled? Can you do like that?
No, sir.
No. The reason was,
Different, means there's a partial differentiation with respect to rho only.
yeah, because rho is a dependent variable here. You are taking the differentiation also with respect to rho. You should not take rho outside. Okay. Most of the people used to do the mistake here only. They used to take rho common and get it cancelled with the denominator here. That you should not do, because the differentiation itself is rho and this is also rho. You should not take rho outside because rho becomes a dependent variable. So the final answer, what it will become, 1 by rho dou by dou rho of rho d rho plus, so get rho multiply with the second term also. So 1 by rho dou by dou phi of d phi, and whereas from the third term I can take rho common because z is the differentiation variable, right? So rho, when you take common and get it cancelled, so final value becomes dou by dou z into dz. So this is the expression for the divergence in case of cylindrical system. So same thing, you try to do it in a spherical also quickly. So in case of a spherical, you consider the vector like this, dr ar cap plus d theta a theta cap plus d phi a phi cap. So what is del dot d in this case now? So h1, h2, h3, in case of spherical, that will be 1 r and r sin theta, right? So h1, h2, h3 can be multiplied 1 by r square sin theta and dou by dou r of, so h2, h3 will be again r into r sin theta, that will be r square sin theta dr plus dou by dou theta of h1, h3 will be 1 and r sin theta, right? So I can say r sin theta d theta plus dou by dou phi of h1, h2 will be 1 into r. So that will be r into d phi. So you can further simplify that. Del dot d is equals to, so from the first term, I can take sin theta as a common and get cancelled with this. So the first term becomes 1 by r square dou by dou r of r square dr plus, from the second term, you take r as a common. So that becomes 1 by r sin theta dou by dou theta of sin theta d theta plus, from the third term also you take r common and get it cancelled, 1 by r sin theta dou by dou phi of d phi. So everybody is getting, or there is some delay in communication? Please reply. Still, is there any delay in the communication? Because I was feeling that when I was writing. Anybody is getting delay?
Now it's okay, sir.
Okay. So finally, what is the summary about the divergence? So the divergence represents the amount of the net outward flux per unit volume. So when you apply a divergence, the divergence must be applied on a vector and the result is a scalar. So we have all these equations and all, you need not to get worried. After this session is over, you try to practice all these equations and then it will be easier for you before going to the problems. That's what. Now, moving on to the next one, the final thing is the curl. So what is actually the curl represents? The curl represents, just a minute. So the curl represents the amount of circulation over a given area. So what is the meaning of that? Suppose if we have a source like this, and if the curl is something like a rotational nature, so the curl is basically represents the amount of the rotational nature of a vector field around the source. So the curl represents the amount of the circulation over a given area. So whenever you are applying a curl, that should be operated on a vector and the result is also a vector. So what is the meaning of that? So when you consider any vector, let us say A is equals to some vector, you can consider AU cap. So plus AV cap plus AW, unit vector is AW cap. Then the curl is defined with a symbol called curl, del cross A. It is basically a cross product. So the input is also a vector and the output is also a vector. So the curl is given by this equation, 1 by H1, H2, H3. And the first row represents a unit vector. You would have been seen in your mathematics also. The same thing I was writing. So the extra adding it here was the scaling factors. So the second row will be the differentials. Second row will be the differentials. Dou U. Something happened. So I will explain the curl here in this slide. So basically the curl of any vector is said to be like this: 1 by H1, H2, H3. So the first row will be the unit vectors: H1 AU cap, H2 AV, and H3 AW. And second row will be the differential vectors: dou by dou U, dou by dou V, and dou by W. And third vector is the coefficients. The coefficients will be AU, AV, and AW with the multiples. And at the same time, if the curl of any vector is basically said to be 0, the vector is said to be irrotational. Or this is also said to be the conservative. So what is the meaning of that? If the curl of any vector is 0, which means that there is no rotational nature. So if we have a source, if there is no rotational nature, that vector is said to be an irrotational. And you can understand the meaning of conservative once I move on to the electrostatics part. So the first curl represents the amount of the circulation over a given area. And when you apply a curl, the input is also a vector and the output is also a vector. And the final summary is, if the curl of any vector becomes null, you should not say it as 0 and it's a null vector, then the vector is said to be an irrotational or conservative. And you need not to see in a rectangular, cylindrical, and spherical. We'll straight away see what will happen when you move on to the problems. So the next thing is the vector identities. So there are three vector identities that were existing. So the first vector identity will be the curl of a gradient. The curl of a gradient is always 0. What is the meaning of that? So if we have a scalar something like k, the mathematically del cross del k is equals to 0. So why the irrespective of whatever the scalar k it is? Why? Because you can see here this looks like the cross product of two vectors. So consider this is your vector a bar and this is your vector b bar. So what will happen? A bar cross b bar is equals to ab sine theta. Now since a is also lies in the same direction of del and b is also lies in the same direction of del. So both a bar and b bar vectors lies in the same direction. So your theta value become exactly 0 degrees. So in this case, your cross product will be straight away null vector. So the curl of a gradient will be always null vector irrespective of whatever the scalar it will be. So this is your first vector identity. And the second vector identity is the divergence of a curl is always 0. So what is the meaning of that? If you consider a vector d, let us say, that says, so del dot del cross d is always said to be 0. I will explain with an example. Let us consider the direction of del lies in the direction of x and the vector d lies in the direction of y. What will happen now? So consider this is your a bar and this is your b bar. So you know that a bar dot b bar is equals to ab cos theta. So what is the angle between theta here between a bar and b bar? So since del lies in the direction of x and d lies in the direction of y, so del dot, if you take the cross product, the angle between del and d will be 90 degrees, right? So what will happen? AB cos theta, that theta will be straight away is equal to 0. In other words, when you take the direction of b bar, say that will be in the direction of del cross d and a bar is in the same direction of del, right? So the resultant of any cross product represents a vector which is perpendicular to both. For example, if you take ax cross ay, the output resultant is nothing but az. So what is the meaning of that? Az is the resultant of any cross product represents a vector which is perpendicular to both the input vectors. So z is perpendicular to x and z is perpendicular to y also. In the same case, you can see here del is represented with a vector a bar, right? So the direction of del d, which is nothing but the direction of b, is perpendicular to vector d is perpendicular to the vector del also. So which means that b bar is indirectly perpendicular to vector a bar. So when b bar and a bar are perpendicular, your theta becomes 90 degrees. So when theta is 90 degrees, straight away the dot product will become 0. So any questions here in this slide? Vector identities? So if you have any questions, I can once again explain at any point. At least one or two people can answer. Yeah, I will move on to the next case right now. Next one is the Laplacian of the operator. So what is the Laplacian of any scalar? So Laplacian can be written on a scalar as a vector. If you take any scalar k, the Laplacian will be defined as del square k. So the Laplacian is nothing but, in mathematics we have seen, it's a second order partial differential equation. So the Laplacian of any scalar is the divergence of the gradient itself. So the del dot del k is basically said to be Laplacian. And one more thing here, if the Laplacian of any scalar becomes 0, that scalar is basically said to be harmonic. The function is said to be harmonic. So the Laplacian of a scalar is nothing but the divergence of the gradient. So if the Laplacian becomes 0, the function is said to be harmonic function. Suppose in most of the question they used to give the scalar function and verify whether the scalar function is harmonic or not. So for that, what you need to do, you need to find the Laplacian of the scalar. So first you find the gradient of that scalar. So it represents a vector. So whatever the vector you got as an answer, for that once again apply the divergence. So if the divergence of the gradient, if it becomes 0, that function is said to be the harmonic function. And the next one is the Laplacian of a vector. So suppose if we have a vector something like this a bar, the Laplacian of a vector can be found out given by del square a is equals to gradient of divergent minus curl of a, double curl of a. So this is a well-known vector identity which we are going to use it in the electromagnetic wave propagation. If you want to prove that you can use a conventional mathematical technique, something like you can assume some vector a and you prove the left hand side and the right hand side. So this is a vector identity which I will come back to this part again in the wave propagation part. You need not to worry about that. So this is one of the vector identity. And the final one is the vector theorems. So the vector theorems also you have studied in mathematics. We'll try to recollect it. So the first one is the Stokes theorem. So Stokes theorem says that whenever the line is closed, if you are finding the line integral of a vector along a closed loop, that can be equated as double integral curl of h multiply with a surface area. So what is the meaning of that? I will explain with a simple example. Suppose in the question, you know one vector field and they are asking you to find out the line integral of h over this particular loop, something like this. Generally, what you will do, let me define it as 1, 2, 3, and 4. If you want to follow the conventional mathematics, in order to find out integral h dot dl, first you are integrating from 1 to 2, and 2 to 3, and 3 to 4, and 4 to 1. So total 4 line integrals you have to evaluate and finally add it together to find out the total line integral. So instead of that, since the line is said to be closed, you can see here, when you move along this particular loop, you are going to cover a surface. So the total line integral when you are moving around this loop is nothing but the circulation of this vector along this surface. So the moment once the line is said to be closed, you need not to calculate the 4 line integral. Straight away you find the curl of the vector multiplied by the area of the loop. So this will be advantageous in order to reduce the number of line integrals you have to be solved. So what is the meaning of that? It says any closed line is basically is said to be an open surface. Will you agree with my point? Every closed line is said to be an open surface. Agree with my point? Or any questions you have, you can ask. Understood? Yeah. So the Stokes theorem is advantageous when you want to find the line integral over a closed loop. So instead of calculating the number of line integrals, something is you can take the curl of that vector multiplied by the surface area. That gives the Stokes theorem advantages. Similarly, what is the divergence theorem says? When you have a closed surface, the closed surface is converted as a volume integral. So what is the meaning divergence theorem says? Double integral d dot ds is equals to triple integral del dot d into dv. So for an example, I will give an example for this also. Suppose this is your point source, or you can say some point charge. It will produce the electric flux in all the. So I know the vector something like a displacement flux, which is coming out from the source. I want to calculate the divergence of this particular vector over the whole surface, something like this. For an example, you can consider the room itself. It's a rectangular kind of room. I want to find the divergence of this vector over the complete whole room. So if you consider a closed room, there are two xy planes, two yz planes, and two xz planes. So in order to find out the divergence of the vector over the closed surface, you need to find out what is the flux leaving two xz planes and two xy planes and two yz planes. So total 6 surface integrals you have to evaluate when you go in a conventional method. But what I say, since the source is here and the surface is closed, the closed surface is automatically having a volume. So the surface integral of any particular vector over a closed surface is exactly same as what is the divergence of this vector over a whole volume. So the divergence theorem is helpful in reducing the number of surface integral into one volume integral. So the integral of the vector d over a closed surface is same as the divergence of that vector in a volume. So double integral d dot ds is said to be triple integral del dot d dv. So what is the meaning of this? Every closed surface, you can consider that it is having a volume associated with it. So the Stokes theorem says every closed line is said to be an open. This theorem says every closed surface is associated with a finite volume. So whenever the line is closed, you can apply the Stokes theorem to convert it into phase integral. And whenever the surface is closed, you can apply the divergence theorem to convert it into the volume integral. So is it clear? Now shall we see some couple of problems on this? Before that, you can try to understand. If you have any questions, we will discuss. Then we will move on to the problems. So you have any questions?
No, sir.
So shall we proceed with the problems now? Some few problems because we don't have the time. So these few problems we'll try to solve in this session, and we'll continue the problems in the next class also. Okay, shall we start?
Yes, sir.
Yeah. So see the first problem. So in this problem, you need to find the gradient of this scalar function. So there is a scalar function k is equal to rho square z cos 2 phi. So you need to find out what is the gradient of this. First of all, the scalar function is in which type of system? Please answer.
Cylindrical.
So what you need to do, write down the equation for this gradient in cylindrical system. So in case of cell, what will happen? Del k is equals to, we already seen, the gradient represents the rate of change in all the directions, right? So the first variation is rho. So you have dou k by dou rho, a rho cap, plus, and the second variation is phi. So you have dou k by phi, a phi cap. And remember, when you have a phi variation, there is a multiplier. We have seen already. There is a 1 by rho. You need to put. And the variation is the z. So that dou k dou z, a z cap. So take the differentiation. So finally, what is the value? So when you take dou k by dou rho, it will be z into cos 2 phi is a constant, and differentiation of rho square will be 2 rho. So the answer becomes 2 rho z cos 2 phi plus 1 by rho is dou k by dou phi now. Rho square z is a constant, and differentiation of cos 2 phi will be minus 2 sin 2 phi k phi cap plus rho square cos 2 phi, and differentiation of z will be 1. So simplify that. So in the second term, rho gets 1 time gets cancelled. So finally, what is the answer you will get? Del k is equal. So 2 rho z cos 2 phi a rho cap minus 2 rho z sin 2 phi a phi cap plus rho square cos 2 phi a z cap. Clear? So there is nothing difficulty, just you can go through all the theory part. The moment once you comfortable with all the equations, then you can straight away apply, and what you require was the differentiation and integration. You have to be very comfortable. That's it. So shall I move on to the question?
Yes.
Yeah, go to the next question. So find the curl of the following vectors. So there are two vectors which has been given. So you need to find out the curl of that vector. So first problem I will explain. The second problem you try to do it afterwards. Okay. So what is the first problem? So you know that since first vector is said to be in a case of rectangular. So what is the curl equation I given? 1 by h1, h2, h3. All the multipliers can be negotiated. So there is no need to worry about the scaling factors in rectangle. So the first row consists of unit vectors ax, ay, and az. And there is a second row, the differentials dou by dou x, dou by dou y, and dou by dou z. And in the third row, you should consider the vector coefficients. So here that will be 3, 7, and 2x. So 3, 7, and 2x. I think everybody would have known how to expand the determinant. So I was doing it that. So ax cap into. So delete this column and delete this row. So what is the minor of this? Dou by dou y of 2x, that will be 0, minus dou by dou z of 7, that will be 0. Similarly, when you write the second term, there will be a minus ay cap. So delete that column and delete that row. So what will happen? Dou by dou x of 2x, that will be straight away 2, minus dou by dou z of 3 will be 0, plus az cap into dou by dou x of 7 is 0, and dou by dou y of 3 is 0. So finally, what is the answer you will get? So there is no ax term and there is no z term. So finally the answer is minus 2 ay cap. So as the last one, you try to find the curl for second vector and tell me the answer. Then we can conclude the session. So take the second vector, 6 row a row cap plus 2 row a phi cap plus 5 az cap. Try to find the curl for that vector and tell me the answer. So be careful about the scaling factor in that case, since it is cylindrical. Six row a row cap plus 2 row a phi cap plus 5 az cap. So try to find the curl for this. Once anybody done, you can share the answers. Done?
2 z cap.
Please cross check. No. So first of all, tell me what is the determinant format you have? Yeah, anybody ready with the answer?
So 4 AZ cap.
Correct. So you can see curl of H is equal to 1 by H1, H2, H3 will be rho, right? So whenever you are writing the first row, remember, if it is other than rectangular, you should multiply the scaling factors. So the first one will be 1 into A rho cap and rho into A5 cap, and this will be AZ cap. Scaling factor 1 rho and 1. And the second row will be straight away, you can say dou by rho, there is no change, and dou by dou phi, and dou by dou z. And the third row will be, you should take the coefficients, multiply with the scaling factors. Take the 6th row, the multiplier will be 1. So you need not to multiply anything. When you take the 5 coefficient, you should multiply with a row for that. So that will be 2 rho square. And when you take the third term, that is straight away 5. So simplify that. 1 by rho, A rho cap into. So dou by dou phi of 5 is 0 minus dou by dou z of rho square will be 0 minus rho A5. Dou by dou rho of 5 will be 0 and dou by dou z of 6 rho will be 0 plus AZ cap into dou by dou rho of 2 rho square will be 4 rho minus dou by dou phi of 6 phi will be 0. So finally what will happen? There is no A rho coefficient, there is no phi coefficient, and Z coefficient will be 4 rho by rho. So the answer will become 4 into AZ cap. So that's it. Now we will see some more problems in the next session. The moment once you practice, I feel it's better we can discuss the problems. So in the meantime, if you have any questions, you can ask. Yeah.
Like always, the curl of a vector will be a single term, means only in one direction.
No. Because it depends. It depends on the problem, right? Basically, the curl represents a vector. It can have all the three components. It doesn't mean that only one direction it is having. Yes. Whatever the problems I have discussed right now, it's a very rare chance that you will get a one component. But generally, it consists of all the three components.
Circulation over a given area means it will be one term, right?
No. How? See, the circulation when you take, suppose if you take a circle, correct? When you take a circle, it corresponding to one variation. As you said, it is a 5 variation. But what I meant to say circulation was, see, when you consider a sphere, right? You are moving on the entire surface of the sphere. Don't you think it is a circulation?
Yes, sir.
When you move on the surface of a sphere, what will happen? All the parameter will change or not? Theta also will change there.
Yes, sir.
Phi also changes. So the amount of the circulation is nothing but the circulation is around a particular source. Correct. It may have all the vectors. It can have theta variation. It can have phi variation altogether.
Okay.
See the simple another example also I can give you. Suppose if this is your source, something like this. Okay, I was moving in this direction. Is it a circulation or not? It may not be symmetrical. Remember, it may not be symmetrical, but is it a circulation or not?
Yes, sir.
The moment once you move along this particular loop, every component changes. So the circulation may not be symmetrical. Suppose if it becomes symmetrical, you may have one or two components. That's it. Other than that, any questions still?
So from where can we practice more questions?
For questions, I suggested you the textbook, right? Sadiku, Elements of Electromagnetics. This one. EMF by N.O. Sadiku.
Okay, sir.
This is the textbook. You can see here, you need not to practice the exercise problems. Whatever the problems they have already discussed there. Worked out examples are already there in the textbook. We can solve more number of problems. Even actually today I thought I can complete the whole problems. I have almost had 10-15 questions in vectors only. Because I don't have the time, I may not be able to discuss in this session. Anyhow, it is good in one sense because you would have been gone through the theory part before the next session. Then the moment once you understand the theory part, if I discuss the problems, that will be well and good. Okay. So don't think that I was discussing one or two problems only, because the problem session will be continued in the next session, right? So questions you have? So,
and when would we get assignments and all of that?
Correct. Now, the moment once I finished the vector calculus part, for both coordinate systems and vector calculus, I was going to a combined assignment, because this is not the core, right? We have not started still gone into the core subject, right? This is the fundamentals which is required, right? So for both coordinate systems and vector calculus, in the next session, I will complete the problems on the vector calculus. Then you are going to get an assignment.
All right, sir.
And in the meantime, what you need to do, you need to practice whatever the theory I have said in coordinate systems and vector calculus. You be comfortable with the theory. By the time the next assignment comes, you should be ready for that. So there are still some more questions which needs to be discussed in vectors. That before that you try to practice all the theory part. And do you have any comments in the theoretical part in the way of explaining? I mean, at some places I have to slow it down, or I have to still increase the speed, or it is getting too much delayed, something. If you have any comments in the way of explaining, you can just share. By the next time, I can try to adjust for that. So do you have any comments? Is it fine? Hello? Yeah,
Yes, sir, it's fine.
it's fine. So the next thing is regarding the tool. Are you getting any delay frequently, or it is occasionally it is happening? Delay.
Only occasionally, sir.
Occasionally. But the thing is, one problem I was facing when I was writing. So initially it looks to be very flexible. I can easily write with my Apple Pencil, but soon after it is getting slower down. So I will discuss all these things with Dinesh sir also. Not a problem. We'll try to resolve. That's it. So that's it. We can conclude the session now. So you can practice all the theory by the next class. We'll try to conclude the session, right? Okay. Thank you very much.
Thank you, sir.
Yeah.
Thank you.
Thank you, sir.
All right. Bye.